Today, HMT brings you the Equations with Absolute Value Starter Pack. Let's start off looking at an observation. We observe that the absolute value of plus or minus 3 will be 3. The idea is that when you take the absolute value of something, you take the positive version of whatever you find in the absolute value signs. So the absolute value of plus 3 is 3, and the absolute value of minus 3 is also 3. This idea underlies everything we do today. For our first question, let's solve the absolute value of x equals to 8 for x. Your first line will be x equals plus or minus 8. Based on the idea that the absolute value of plus or minus 8 is 8, so that x takes on these two values in the absolute value signs, just where x is now in the absolute value signs. After that, you list out your values for the teacher, 8 or negative 8. Put in your therefore signs, and you have a complete solution. Let's try another question. Solve this. The absolute value of x minus 1 equals 12. Well, again, your first response will be therefore x minus 1 equals plus or minus 12, based on the idea that the absolute value of plus or minus 12 is 12, so that x minus 1 takes on these two values. Split it into two equations, and the next line will be x minus 1 equals 12 and x minus 1 equals negative 12. Add 1 to both sides, and x is 13. Add 1 to both sides, and x is negative 11. Gather those answers together for the teacher, and you have therefore x equals 13 or negative 11, listed in any order, separated by a comma. For our next example, we're going to solve this. 2x minus 3 equals negative 4. Absolute value of 2x minus 3 is equal to negative 4. Well, there's a problem. This is a trick question. You have to be on the lookout for this question type because they frequently make their way onto tests. This is a non-negative quantity. Because it has absolute value signs, this could never be less than 0. So how could an absolute value be equal to a negative? It can't. So at this point, you should just say there are no solutions. In this case, the left side is greater than or equal to 0, while the right side is less than 0. They cannot be equal. For our next example, we're going to look at a case where the right side is a function of x. So let's see how that works. It's a little trickier. There's a first step you must observe before you continue. So we are required to solve the absolute value of 2x minus 4 equals 3x. Now remember what we just saw in the last trick question. This is an absolute value, so this could never be negative. So we should observe that the 3x is greater than or equal to 0. Divide both sides by 3, and we get what we call the domain of the solution set. Any potential solutions must come from this set of numbers which are greater than or equal to 0. If our calculations lead us to get a negative number for an answer, we must discount it immediately because the right side must be non-negative. Okay, let's get started. You proceed the usual way. You say, therefore, 2x minus 4 equals plus or minus 3x. Then you change it or split it into two equations. So that gives us 2x minus 4 equals 3x, and 2x minus 4 equals negative 3x. So solving these, we get, subtract 2x from both sides here, and you get an immediate solution of negative 4. But that's inadmissible, because any x values we get must be greater than or equal to 0. So this guy, we'll circle him and put a label on it for the teacher. We'll say inadmissible. Not allowed as an answer. Let's solve this one. So here what we'll do is we'll subtract 2x from both sides, and that gives us -4 equals -5x. Divide both sides by -5 now, and we get 4/5 equals x. It passes the domain test. This is a positive number, and this is a valid solution. So we'll give that one to the teacher as our answer. Thank you. If you enjoyed the video, please like, subscribe, and share. If you have suggestions on topics you'd like to see covered, please leave those in the comments below.